Today in this video, numerical on strength of material subject. Numerical is a high strength steel band saw. This is saw. Steel band saw with width 20 mm and thickness 0.8 mm. Runs over a pulley of diameter. This is diameter, total diameter 600 mm and radius 300 mm. What maximum flexural stress is developed? This pulley. And what minimum diameter pulley can be used without exceeding a flexural stress of 400 MPa. And take modulus of elasticity E is equal to 200 GPa. That means in this numerical we have to calculate what maximum flexural stress is developed, this pulley, and what minimum diameter pulley can be used without exceeding the flexural stress. So first write given data. Width of this steel band saw denoted as small b is equal to 20 mm. Thickness denoted as small t is equal to 0.8 mm. Runs hole of pulley 600 mm in diameter. Diameter of pulley denoted as capital D is equal to 600 mm. What maximum flexural stress is developed? Flexural stress is denoted as sigma. And what minimum diameter pulley can be used without exceeding a flexural stress 400 MPa. That means flexural stress is not exceeding 400 MPa, without exceeding. And E is equal to E Young's modulus or modulus of elasticity 200 GPa. That means 200 into 10 raised to 3 MPa. And we have to find sigma max, maximum flexural stress, and diameter of pulley, capital D, diameter of pulley for without exceeding a flexural stress. And now diameter of that pulley is 600 mm. And we have to calculate without exceeding a flexural stress 400 MPa. So calculate maximum stress developed in the steel band saw. Case 1. Sorry for this handwriting because of this notepad and pen. But we have to calculate maximum stress developed in the steel band saw. Now first calculate position of neutral axis. For this steel band saw, position of neutral axis is thickness by 2. That means position of neutral axis denoted as small y is equal to thickness by 2, and thickness of that steel band saw is 0.8 mm. That means 0.8 by 2. That means 0.4 mm. Now next calculate moment of inertia. Moment of inertia denoted as capital I is equal to, for that steel band saw, moment of inertia about this I x axis is sorry 20 as it is into 0.8 cube by 12. And this is 0.8533 mm raised to 4. This moment of inertia is about x-axis. Now next use Flexner formula. Flexner formula is m by I is equal to sigma by y is equal to E by R. Now we have this I, y, that means this I, y, we have this moment also. Sorry, we don't have moment, we have E. So, see, we have I, we have y, we have E, and we have R also. So, use these two terms, because with the help of these three terms we calculate sigma. So use sigma by y is equal to E by R, and sigma is sigma max here. Sigma max is equal to E by R into y. Here E is 200 into 10 raised to 3. Y is y here neutral axis we calculate in step 1 0.4 mm, and R is 300 mm. See here R is 300 mm. Pulley radius. So 200 into 10 raised to 3 into 0.4 divided by 300 is maximum stress. We stress maximum flexural stress developed is 266.67 MPa. This is maximum flexural stress developed, 266.67 MPa. Now next we have to calculate diameter for that pulley in which without exceeding flexural stress. So case 2, minimum diameter of pulley without exceeding flexural stress. Here minimum diameter of pulley can be used without exceeding a flexural stress. So use same formula, this sigma max is equal to E by R into y. only here sigma max put this value 400 MPa, because without exceeding a 400 MPa, that means this stress value comes up to 400 MPa, up to 400 MPa and below 400 MPa. For that much stress, we have to calculate diameter of this pulley. So use 400 MPa critical value. Don't use above this 400 MPa value, because we have to calculate minimum diameter without exceeding a 400 MPa. So use critical value 400 MPa is equal to E by R. E is our E is 200 into 10 raised to 3 MPa. Y is this 0.4 mm, and R, that means diameter by 2, radius is diameter by 2, or we have to calculate diameter. Yes, radius is diameter by 2. There, now no, now next solve this equation mathematically. Therefore 400 is equal to 200 into 10 raised to 3 into 0.4 into this d by 2 is inverse, that means 2 by d, 2 by d, and this d term take here, that means d is equal to 200 into 10 raised to 3 into 0.4 into 2 divided by 400. Therefore this d is equal to 200 into 10 raised to 3 into 0.4 into 2 divided by 400 is 400 mm. So 400 mm diameter pulley is required for this 400 MPa stress. So see this figure, this is pulley and steel band saw arrangement. For that pulley and steel band saw arrangement, steel band saw is 20 wide, 0.8 mm thick, and pulley is 600 mm diameter. Maximum stress on this pulley is 266.67 MPa, and for maximum 400 MPa stress, diameter of pulley required is 400 mm, and our pulley diameter is 600 mm. That means this pulley is safe for gain this 400 MPa stress. Thank you very much.